Okay guys, this is the Angle Relationships notes for pre-AP. So this is stop 1, pit stop A. There are 4 types of angles that we're going to learn about. Okay, the first one is going to be complementary angles. Complementary angles. So the way I remember complementary angles is I can take this C over here and I can connect the ends and turn it into a 90 for 90 degrees. So complementary angles are 2 angles with measures that add up to 90 degrees. 90 degrees. So again, you can take the C in complementary, connect the ends, and turn it into a 9 for 90 degrees. That's your trick to help you remember that. Okay, so here, angle 1 and angle 2 are considered complementary. So this is the symbol for angle. So if you need to mark that down, you will see this a lot. Sometimes you may also see us write it this way. Same thing. Those both mean angle. So angle 1 and angle 2 are complementary. That means that when I put them together, they equal 90 degrees. Notice you see this angle right here is a 90-degree angle, and it makes an L, okay, a right angle. And if I were to add angle 1 and angle 2, they would total up to 90 degrees, so they're considered complementary. Another way you could write this is by naming the actual angle using the letters. So you would start at the end of your angle, go to the middle, and then out to the end. So this would be considered angle ABD. You could say angle ABD is complementary to angle CBD. Angle CBD. You could also, instead of ABD, you could do DBA. It doesn't matter which way you go as long as you start at an end, go to the middle, and then back out. Same thing with this one. We did CBD. You could have done DBC, whichever works for you. Okay, so if I were going to find the measure of X, I'm looking at my picture. I know this is a right angle, so that I know that these 2 angles, 75 and X, have to add up to 90 degrees. So I know that X plus 75 has to equal 90 degrees. If we remember how to solve a one-step equation, we cut it in half at the equal sign. Then we want to isolate the variables. We want to get the variable, or X, by itself. So I'm going to do the inverse operation. That's the opposite. So the opposite of adding 75 is subtracting 75. And what I do to one side, I have to do to the other. These 75s cancel because 75 minus 75 is 0. And then 90 minus 75 is 15. So X equals 15. I could always solve this, or check it by plugging it back in. 15 plus 75 should equal 90, and it sure does. So we're going to do the same thing up here on this one. I know that these 2 angles have to add together to equal 90 degrees. So let's write our equation. 35 plus 4x plus 7 has to equal 90 degrees. Over here on the left side, I can combine like terms or things that are similar. So my numbers are similar. I can add those 2 things together. 35 plus 7 is 42. And then I still have 4x equals 90. Okay, so I'm going to cut this in half. In order to isolate the variable, I have to get rid of the constant, or the number, first. So the opposite of positive 42 is negative 42, or subtracting 42. I'm going to do that to both sides. This one cancels. I'm only left with a 4x. 90 minus 42, well, 10 minus 2 is 8. 8 minus 4 is 4. So 4x equals 48. Then I'm going to cut this in half. To isolate this variable, the opposite of multiplying by 4 is dividing by 4. Do that to both sides. 4 divided by 4 cancels. 48 divided by 4 is 12. So in this case, x equals 12. I can plug that back in to check. 4 times 12 is 48, and 48 plus 7 is 55. So if this angle is 55 and this one's 35, if I add them together, I do get 90. So I know that my answer is correct. So remember, complementary angles, you can turn the C into a 9. C for complementary, that's 90 degrees. They add together to equal 90 degrees. Supplementary angles are very similar. Instead of 90 degrees, supplementary angles are two angles that with measures that add up to 180 degrees. So a horizontal line is 180 degrees. My trick for that, like over here with a complementary, if I connect my two ends, that makes an 8 or 180 degrees. All right, so supplementary 180. Same process as complementary, but now instead of adding up to 90, we're going to add up to 180. So I know that 3x plus 54 is going to have to equal 180 degrees. So if I want to solve for x, I can write out my equation. 3x plus 54 equals 180. I'm going to cut it in half. I want to isolate my variable, so I want to get rid of this constant first. The opposite of adding 54 is subtracting. 54 minus 54 is 0. I still have 3x on this side. I'm going to subtract 54 from this side also, because what I do to one side, I have to do to the other. Need to borrow. 10 minus 4 is 6. 7 minus 5 is 2. And 1. So 126. Final step, I'm going to cut this in half. The opposite of multiplying by 3 is dividing by 3. I'm going to do that to both sides. And 126 divided by 3. 3 won't go into 1, but it goes into 12 4 times. 3 times 4 is 12. 12 minus 12 is 0. Bring down my 6. 3 goes into 6 2 times. So x equals 42. Final answer. You can always check this by plugging it back in. If I plugged in 42 in for x up here, 3 times 42 is 126, and then 126 plus 54 is 180. So I know my answer for x is correct. Over here, let's try this one. Find the measure of y. So y plus 77 is going to have to equal 180 degrees. I'm going to cut it in half. I want to isolate my variable, so I'm going to get rid of the plus 77 by subtracting. I'll do that to both sides. Those 77s cancel. I'm left with y. 180 minus 77 is 103. So y equals 103. I could plug it back in. 103 plus 77 is 180, so I know I did it correctly. Here's just another example saying a plus b is 180. The other two types of angles we're going to learn about are adjacent and vertical. Okay, so adjacent angles have a common vertex and side. Vertex is the point where they all come together. It kind of looks like a V. So at the middle of this V, where they all come together, is the vertex. They are neighbors. So the story I like to tell for this one to help you remember it, sorry, that's an H, is my neighbor's name in college was Jason. This is a true story. My neighbor's name in college was Jason. So Jason was adjacent to me. We were neighbors. So that's just a little story for you. So I'll put it down here. Jason was my neighbor. Jason. It's like adjacent to help you remember. So Jason was adjacent to me. He was my neighbor. So here, angle A and angle B are considered adjacent. So I like to use colors because sometimes this helps. So we'll say angle A is green and angle B is orange. So this is like angle A's backyard and that's angle B's backyard. And if you notice, they share a fence line. So think about your backyard at your house. Chances are your neighbor and you in the backyard, you share a fence line. So if you were back here, you could look over the fence and see your neighbor. So angle A and angle B are considered adjacent because they share a side right here, and they have a common vertex or a common point where they come together. The vertex for A is right here, and then the vertex for B is right here. Remember, vertex is like a V, V for vertex. Where those points meet at the bottom of the V is the vertex. Down here, if we're looking, angle C and angle D are considered adjacent because they're neighbors. They share this side and they have a common vertex. But if you look over here, X and Y are not adjacent. There's some room in between them. They don't share a common point. These points aren't the same. They're not touching like they are here. And these sides are not the same. So this is like somebody's backyard and somebody else's backyard, but there's an alleyway in between. So their fences aren't touching, so they are not considered adjacent. So let's use that knowledge and come over here. And I'm going to use some colors again. I'm going to do green for angle R. I'll do yellow for angle Q. I'll do blue for angle T. And we'll do some orange for angle S. I think colors just help us. We're visual learners. Okay, determine all the adjacent angles from the picture above. So let's just look at blue, or angle T. So angle T, who are angle T's neighbors? So if angle T is in his backyard, whose fence is he looking over to say hi to? Well, he would say hi to angle Q. They share this fence line. So angle T and angle Q. And then we've got angle T and who are his other neighbor on the other side of his fence is angle S. So they're adjacent. If I go across to angle R's neighbors, so here's angle R backyard. On this fence line, he's going to look over and see angle Q. So here's angle R again. On his other side of his fence in his backyard, he looks over to angle S. Angle S's neighbors would be T and R, which I already have here. S and R, T and S. Okay, and angle Q's neighbors, so his fence line, is angle T and angle R. So yellow and blue, yellow and green, yada yada, which we already have written down. So those are all the adjacent angles. So just remember, my neighbor's name in college was Jason. Jason, he was adjacent to me. He was my neighbor. We shared a fence line. And the last one you're going to learn about is vertical angles. Vertical angles are two non-adjacent, okay, so they're not neighbors, so non-adjacent angles that are formed by two intersecting lines. Vertical angles are always opposite, or it's probably better to say across. They're always across from one another, and they are equal. They're equal. Okay, so I like to bring my colors back in here. I'm going to color angle 1, angle 3, angle 2, and angle 4. Alright, so if I'm using my colors and I want to determine all the vertical angles, here's a trick for you down here. Vertical angles, see how they're opposite from one another? They're only touching at this point right here. Okay, opposite or across from one another. So if I'm looking at angle 1, angle 1's vertical angle, so if this is where angle 1's house is, let's say, if he stands on his back porch and he looks directly across from him, who does he see? Angle 3. So angle 1 and angle 3 are vertical angles. And then I could do the same thing for angle 2. I turn it sideways. If you're standing on your back porch and you're looking directly across from you, angle 4 would be your vertical angle. So angle 2 and angle 4 are vertical angles. So just remember, adjacent angles are neighbors. They're side by side. Okay, they share a common side. But over here, vertical angles are across from one another. So directly across. Okay, so we also said that vertical angles are equal. And if you look at this angle right here looks to me to be about the same size as this angle right here. Okay, those are equal, they're the same size. So if I want to solve for y, all I have to do is set those two angles equal to each other, because I know this has to equal this because they're the same thing. So 11y minus 36 has to equal 63. And all I do from here is just solve. So I'm going to cut it in half. I'm going to isolate my variable by getting rid of the constant first. So opposite of subtracting 36 is adding. Those cancel. I'm going to do the same thing over here, and I get 99. I still have 11y on this side. I'm going to cut it in half again. I'm going to do the inverse or opposite operation. So the opposite of multiplying by 11 is dividing. What I do to one side, I have to do to the other. And 99 divided by 11 is 9. So y would equal 9. If I were to plug it back in, 11 times 9 is 99, minus 36 is 63, which is what the other side is. So I know that they are equal, and I did that correctly. These are your notes for angle relationships. So complementary, you can turn into a 9 for 90. Supplementary, you can turn into an 8 for 180. Jason was my neighbor, so he was adjacent to me. It's angles that are neighbors. And vertical angles are angles that are across from one another. Notice they make a V and an A, vertical angles. Okay? And vertical angles are always equal. Always, always, always.